Hey guys, this is just a quick video on how to find the least squares regression line and the correlation coefficient when you have two sets of quantitative data. Okay, so we would want to start by entering the data into our calculators by hitting Stat, Edit. We could put, for example, this one age in the list 1 and number of teeth in our list 2 column. You can see I've already done that. So from there, to get the least squares regression line, we want to click Stat, scroll over to Calculate, and there's two options. Okay, we have number 4, lin reg ax plus b, which is more like algebra, mx plus b, and then in stats, the way you'd see it in textbooks is actually a plus bx, where a is your y-intercept and b is your slope. So let's choose that. We're going to hit enter. X list should be list 1, y list should be list 2, frequency list is blank. Store regression equation, we're going to leave that blank for right now. Let's hit calculate, and it actually does give us our equation. Y is equal to a plus bx, where a is this number and b is that number. Okay, so remember, a is your y-intercept, b is your slope. So we could write this equation. You see I have it written down here two different ways. Y hat is equal to 0.0357 plus 1.8929x, but the issue with that is you want to define what x and y hat represents. So you could always write it like this. Predicted number of teeth is equal to 0.0357 plus 1.8929 times the age. Okay, now that did not give us the correlation coefficient. So one thing we could do, we actually have to fix these calculators. So we have to go into the mode button here. And if you actually scroll up, and you can get there quicker, there's this stat diagnostics button. It's default to off. We want to hit that on, hit enter, and let's go back into stat, calculate, down to number 8, linear regression a plus bx. Same thing, let's calculate, and now all of a sudden they give us both r and r squared. Okay, so our correlation coefficient r is actually 0.99. We'll say 5. Okay, so that is a really strong positive linear relationship. Okay, other things we could do with these calculators, we could actually look at the scatter plot. So we would want to go into stat plot, which is up here. You have to hit second y equals for stat plot, and then we want to go into our first plot, turn it on, make sure scatter plot is chosen, make sure you're looking at list 1, list 2. Hit graph. And it's not really a great scatter plot, so anytime we want a statistical graph, we want to hit zoom 9 on the calculator because that's zoom stat. So zoom 9, and there you have our scatter plot. Okay, from the scatter plot, we can tell it's a linear, positive linear relationship. Now let's say we want to put our linear regression equation on the scatter plot. We can do that. We just have to go back to stat, calculate, lin reg, and then when they say store the regression equation, we are going to do that. We want to store it under a variable, so we're going to hit this vars button, and we're going to go over to y-vars and hit enter on function. We're going to save it as our y1. Okay, calculate. It's going to calculate the same information we did before, but now look what happens when you hit your y equals. That equation is stored in the y equals. So if we go back to our graph, now we have our scatter plot and our linear regression equation. One last thing we could do is we could look at the residual plots. So first what I would want to do is go back into my y equals and clear this out. And then we're going to go back into our stat plot. And remember, residual plot, all we do is instead of looking at the actual y-axis, we look at the residuals instead. So we're going to get rid of L2 and we're going to go into second, stat, which brings up all your lists. We're going to bring up this resid list. Okay, from there, we'll hit graph, and then we're going to hit zoom 9 for zoom stat again. And there's your residual plot, and we can tell this kind of looks like random scatter, which just means the linear model is a good fit. Thanks for watching.